Okay, so myself, Dr. Amit Kumar Yadav. So I am assistant professor at the School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. So in today expert talk, we will see the concept related to deep learning model for air quality forecasting. So, as we all know that nowadays this air quality is a major issue regarding the health. So here first we will take what do we mean by this air quality, air pollution. So it means some hazardous material present in surrounding which affect human life, climate and environment, and it is mainly caused by say human made sources. So here we are having say two types of air pollution. First, there is primary source which emit directly into the air, and these are carbon monoxide, particulate matters. Then we are having nitrogen oxide, volatile organic compound, sulfur dioxide. Then we are having secondary pollutant, which is found by chemical reaction in atmospheres. And secondary pollutant are say nitric acid, ozone, and say sulfuric acid. This air pollutant come from fossil fuels, burning, cooking, heating, and burning wood, livestock, emission, fertilizer, pesticide, car, truck, and aeroplane. So these are say different types of say air pollutant. So how we can measure this air pollutant with the help of air quality index. So, our air pollution level is considered as good if it is less than, say, 50, and hazardous if greater than 301. So, if we consider this, most of the metro cities, there in that area, the air pollution is not good. So therefore, there is a need of study to how we can minimize this air pollution level, uh, and how we can estimate or forecast this air pollution level, so that it is important for patient to take say early precaution. So So the main part related to say air pollution, that we can measure this air pollution with the help of say different types of measuring instrument. As we know that this measuring instrument is of high cost. Therefore, in India, most of the sites are not having installed this type of measuring instrument. So therefore, we have to develop the artificial intelligence model so that we can estimate air pollutant value based on say past data. Now, environmental pollution classification. Here we are having say pollutants, then environment. In pollutants, here we are having this radioactive, biologicals, then here we are having chemicals, industrial, smokes. And apart from this, we are having here say thermal, noise, marine, then smoke, then oil. So in environment we are having this air pollution, water pollution, soil pollution. These pollution completely affect our daily life. So now, how we have to build the predictive model? What are generalized steps which we have to consider in building the predictive model for air pollutant prediction? So first of all, we have to collect the data. When we say here collection of data. It includes air pollutant input variables like say wind direction, wind speed, or you can say that relative humidity on which this air pollutant depend. And in air pollutant variable, we have to take say PM 2.5, PM 10, NO, NOx. Then we have to pre-process the data. There are different types of technique which we are using for say pre-processing of data. First technique we can use a min-max technique, in which we have to normalize the data between say 0 to 1. Why we require say pre-processing of data? Because it increases the training speed of the model. Then we have to choose the model. Choose the model here means we have to apply say different types of AI model. Say for example, artificial neural network model with one hidden layer neurons, or with two hidden layer neurons, or we can take say radial basis function neural network or generalized regression neural network. Apart from this, we can take say um, uh, LSTM, gated recurrent unit model, or say transformer models. So we have to select the model once we have pre-processed the data. Then once we select the model, or once we choose a different types of model here, then we have to train the model. How we will train the model? On the data which we have collected. First we divided the data into say input features and target variables. So we have to take 80% of data for training the model, and 20% of data for say testing the model. This is called as a and say training of model. Then we have to evaluate the model. So there are different types of say error matrix which we are using for evaluation of model, like say root mean square error, mean absolute percentage error, R value. So these are we are using for evaluation of model. Once we evaluate the model, then we have to see which model is having less prediction error. Then we have to take that model for say for uh, for prediction value, right? So once we are able to find out most accurate model, then we have to deploy the model with different facilities what we are having. Then once we deploy the model, then we can use that model for prediction of say unknown value, right? On unknown inputs. So these are say generalized step which we have to follow in building of say predictive model. Now, why predict air pollutant? So it is important for protecting human health, environment protection, climate change mitigation, government policy support, public awareness, and say behavior changes. So the necessity to predict air pollutant is shown in below figure. So first one say human health protection. So here it will provide you say early warning system, reduce health risks, minimize healthcare cost. Then for environmental protection, uh, what we can achieve, like say agriculture yield protection, rain formation reduction, then here ecosystem damage protection. Then in say climate change mitigation, what we can achieve by this air pollutant prediction, such as say greenhouse gas emission reduction, urban planning improvement. And for government policy supports, we are using here data driven decision making, industrial regulation, smart city development. Then what are say different types of air pollutants say prediction model? First we will take here say general artificial neural network models. So these AI models are widely used to predict air pollutant. So by using say past trend in say data, and we have to identify the patterns. Now, when we take here artificial neural networks, so it is motivated by human brain, and it consists of neurons that work together to process information. For air pollutant prediction, the input, or you can say that the input features, input variables could be say temperature, humidity, traffic, while the output is the level of air pollutant. So, what are say different advantage of this ANN models? It it model complex relationship and work well for say different types of data. So where there is advantage, there is some also disadvantage. So it requires large data set and it is computationally intensive. When we say here computationally intensive, it means that it requires say sometime larger time for say training, or it requires a large memory of say GPU and CPU. So the limitation with this model, it suffers problem from say overfitting, and you can say that underfitting. So each and every model, this overfitting and underfitting is very important. So when we see here overfitting, it means that model learn too much from say training data, and model perform well on training data but poor on new and unseen data. Then, what do you mean by this underfitting? So, model is too simple to learn the underlying patterns in the data. So, it performs say poorly on both training and testing data. So, this is the ANN based air polluted prediction. Here, 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 this is say input layers. Through input layers, we have to provide different types of input features or variable on which air pollutant depend. Then after this input layer, here we are having this hidden layer. Here we are having this hidden layer. On hidden layer, this computational analysis take place. On hidden layer, this hidden layer contains say different types of say activation function. So if we take say sigmoid activation function or other activation function, right? And say in output layers, here we are having this air pollutant, right? Air pollutant. So after air pollutant, here we are having air quality index, and on this air quality index, we can do this health monitoring. So by seeing this picture, it is very useful for say every individual. So so to understand, so what will be say air pollutant value in upcoming time. Now, after this, one simple model which we can use is a support vector machine. It predicts whether air pollutant level will be high or low, which is based on input features such as humidity, wind speed. The advantage is it is effective with small data set and handle high dimensional data. The disadvantage is choosing right kernel and slower bit larger data set. So this is the main disadvantage of say support vector machine. And when we consider its limitation, it require hyperparameter tuning, not predictable for new data set. Then we consider here another model such as say random forest. It is a group of decision tree which is making its own prediction and average the result. So it is popular model for predicting air pollutant and it handles different types of weather condition, input data and say traffic density. The disadvantage is it handles the advantage it handle missing data, reduce overfitting. This is the important, you can say that advantage of the random data. It reduce overfitting. It means that that it give good result on new or unseen data. And the disadvantage is that it requires hyperparameter tuning and say slower uh, prediction. And it is also computationally expensive and say interpretably, because we cannot interpret it as it contains say so many layers. Okay, so many layers of say input variable, hidden variables, and you can say the target variable, so we cannot interpret it easily. So this is one of the limitation of this model. Then come here another trend of model called as a LSTM, long short term memory model. So what are say disadvantage of this ANN model, which is have been say back propagation algorithm, that it is not able to remember say longer sequence of the data. So, but apart from this, there is a Bayesian gradient type of problem when we uh, in a in say longer sequence of data in say ANN model with say back propagation algorithm. But this problem gets solved with the help of say LSTM model. So that's why it work well with say time series data, right? And since air pollutant level it depend on say previous value like last big pollution level, LSTM model are perfect for this kind of prediction. The advantage of this model, it is designed for sequence of data like air pollution level over time, and this LSTM retain information from the past, and it is useful for predicting future pollution level based on the trend. It requires lots of computing sources when especially when processing large data set. This need a big quantity of historical data to train effectively. The limitation of LSTM that it requires long time due to the complexity of the models. So nowadays we are using this type of model, that is LSTM, for say forecasting of say air pollutant. Now, this LSTM, it is a type of say recurrent neural network, and it is mainly designed to overcome uh, the limitation of say traditional recurrent neural network, particularly the vanishing gradient problem. Because in the recurrent neural network, this vanishing gradient problem is most common. So what do we mean by this vanishing gradient problem? Gradient means the slope, that is the partial derivative of error with respect to weight. So when we apply here say chain rule of differentiation, the gradient will become zero, and the weight updation equation, when we see here, say wi plus 1 is equal to wi minus alpha partial derivative of error with respect to weight. And once this gradient will become zero, the weight updation is equal to the initial weight. You can say that weight will not get updated, right? The weight will remain the same. So once your bait will remain the same, you will get more error, right? Means your error cannot get minimized, right? So therefore, this LSTM are especially used for say natural language processing as well as say sequential data types. So, what are say key features of LSTM? First, it contains a memory cells. Memory cells means LSTM has memory cells. It can maintain information over long sequence. Due to this, it captures long-term dependency in data, and it has a gating mechanism, means it has three gates which are used to regulate the flow of information. First, here we are having this forget gate, decide which information to discard from the memory cell. Memory cells. Input gate control which new information to store in the memory cells. Then we are having this output gate. It regulate what part of memory is used to compute the output at each time step. So if you consider this LSTM, that is long short-term memory, it works in the same way. Suppose you are reading the book and your mind remember say important information from say from say different base number, and your mind is forget used to forget say less important information, and this important information get updated with new upcoming information. So in the same way this LSTM is working. So here forget gate, input gate, and say output gate. Now this is the say pictorial diagram of say LSTM. As we have seen, it has a forget gate, input gate. Then here we are having this candidate memory, then output gate. So from output gate, we used to get the uh, we used to get say output, and in say candidate memory we used to say retrieve the important information, and this forget gate is used to discard less important information. Now for here, here when we see here, say LSTM architecture we can use for say solar radiation prediction, wind speed prediction. Apart from this, we can use it for say you can say that air pollutant prediction. So this is one of the architecture. You can say that we can represent this architecture in this way also. Now every model has certain mathematical equation on which it is working. So when we consider the architecture of LSTM, it has a cell state means memory unit. Then here we are having hidden state means output of LSTM unit at each time step, which can be passed to the next input. Then we are having forget gate. It control what proportion of the previous memory to retain. Okay. So by using this expression, this forget gate is working. Then here we are having input gate determine how much of new input data, new input should be added to the memory. Candidate's memory here the temporary memory update based on the input. Then here we are having output gate. Then here we are having this final memory update. So why we are interested in using LSTM? Because it is used for overcoming the vanishing gradient problem. Because this traditional recurrent neural network, it struggle with learning long-term dependency as gradient diminishes as they propagate back through time. And this LSTM solve this by maintaining a more constant gradient over time step. So it captures long-term dependency. It is particular. useful for tasks where context over long sequence, such as speech recognition, machine translation, and say text generation. Then flexibility, it can effectively learn when to retain or forget information over time, making them highly adaptable to various type of sequential data. So, how we can evaluate the performance of these models with the help of say different parameters, say mean absolute error, root mean square error, mean bias error, or coefficient of determination. So, by using mean bias error, it tells us about underestimate and overestimate of data. If we get say positive value, it indicate overestimate of data, and if it is negative value, it indicate underestimate of model. Low mean bias indicate unbiased prediction. Then we are having mean absolute error. It provides direct measure of say prediction accuracy, and it calculate absolute disparity between actual and predicted value. Lower mean absolute error signify better accuracy. It does not cancel out say negative and say positive error, and therefore it is easy to interpret, and it is useful for say practical application. Then here we are having say root mean square error. It is widely used to assess model accuracy. It made it measures say prediction errors, standard deviation, and is widely used to assess accuracy of model. Lower RMSE means better performance of model. It is highly sensitive to large error. R square measure the proportion of variance in actual value given by model, and its value varies from say 0 to 1. If it is close to 1, it means model present more variability in air pollutant data, and if it is close to 0, means model fail to track variability and indicates a poor performance. Now we will see one say case study of this. You can say that hands-on practice here. So, suppose we have to predict this. Suppose we have to predict this air pollutant variables with the help of say Python programming. So, first of all, we have to take the data in the say Excel file. As we took the data here, say in Excel file. Okay, so we have stored in the data in say Excel file in this way. Okay, so we are going to forecast this PM 2.5 value. Therefore, we should keep this PM 2.5 value in the Excel. Next, what important command we have to put here in say Google Colab. Okay, so this software we can run easily online. So first of all, we have to import pandas at PD numpy as NP. Then why we are what are the important function of pandas and numpy? It is used for say data manipulation. Then here we can use it's a matplotlib plotlib say pyplot as a plt. Why we are using this one? For plotting result. Then here we have to import this um, sklearn matrix. It provides error matrix like mean absolute error, root mean square error, r square value. Then here we are having min max scalar. It scale data to a range say 0 to 1. After this, we have to split the data into say training and testing, because our model have to do say training and testing. Then we have to go for say train test split. This This code will help in splitting the data into say training and testing. Then we have to write down this TensorFlow Keras. This is a library for say deep learning library for ANN and say LSTM model. So we have to import this dense LSTM library in order to run our program. Then here our data is stored in Excel. So how we have to upload the data in this program. So upload say Excel file here. Uploaded is equal to say files dot upload. Then we have to read this Excel file. Read this Excel file. Then here we are using say next iteration upload. Get the file number from uploaded directories. This command dot dropna remove rows with missing PM 2.5 values, because in Excel sometime we are having missing value of air pollutant variables. So when we are using this command, this remove a row, this we are having missing value, because once the value is missing, we are not able to run the model. Then after this we have to normalize the data. So what important code which we are using here for normalization, that is a scalar min max scaling scalar, right? So it normalize the data say between say 0 to 1. So this scaling is important to speed up training, right, and makes model work better. Okay, so this is the important, you can say, that function of the scaling. After this we have to create a sequence, because this is related to say forecasting of say air pollutant variables, right? So we have to uh, take say past value in order to forecast the future value, right? So here we take say 7 day past value in order to predict the next day value. So therefore, we have to write this standard command. After this, we have to write this LSTM code here. So LSTM expects a 3D input, means samples, steps, and say features. Here you will find out one part, that is shuffle is equal to false. What it means? It means the past data is used to predict the future value in say time order, right? So in forecasting, time order should be maintained, but in prediction we should take say average value, or we can take say daily value. Then here means ANN model, ANN input here. ANN does not use a time step, so we flatten the data into say two-dimensional. So first one says samples and say here features. Then here in ANN model, so here we are using say sequential. Then here activation function we are using say ReLU function, because this ReLU function, mathematical expression of this ReLU function is say max of 0 comma x, right? So so if you if your value of say net x or net input to any neurons is less than say less than say 0, or if it is negative it will provide you say 0, right? So therefore we are using here say ReLU function. You can use here say different types of activation function based on say different application, right? So then here we are having ReLU activation function, allow model to learn say complex patterns. So input shape, number of features. Here example 7 days is equal to 7 inputs. So when we are using here ANN model compile optimizer Adam loss is equal to MSC, right? So after this here, this what is the meaning of this optimizer, Adam? It optimizer that adjusts the bait efficiently, because this bait play an important role in providing the output, and it is variable. So that's why with the help of this Adam optimizer, we are able to adjust the bait efficiently. Then how we have to evaluate the error? With the help of say mean square error. So once we are using this mean square error, it minimize say error between say target and say output variables. Then here bar pose is equal to 0, it suppress say training output. After this here LSTM model, so here we just fix number of neurons activation function, this optimizer Adam, okay, because this is used to efficiently fix the bit. Then we can use this Y prediction ANN model X test.an. Again, Y prediction LSTM model, LSTM predict X test LSTM, because here in this course we are using one simple ANN model, one say LSTM model. And again here we have to rescale the prediction. So y test is the 2 pm2 point value in normalized form, because before the start of the program we have seen that we have to normalize the data, so that it comes in the range say 0 to 1, right? So then we have to reshape it the data. So -1 say +1, convert say one dimensional data into two dimensional data, because say inverse transfer needed. Then we are having scalar dot inverse transfer, convert value back to original PM 2.5, flatten, convert 2D back to 1D array for plotting or say uh, comparisons. Then how we have to evaluate the model? So just we have seen say different statistical metrics. So first one say mean absolute error, right? So here you should write y true and y prediction. Root mean square error, y true and y prediction. Mean bias error, r square value. Then we have to print all this value here to get the result, right? So once we evaluate the model, then how we have to observe this with the help of certain figure. So here we should go for say plot figure size 12:6, okay. Then here actual PM 2.5 line with 2. Then here ANN prediction. Here this is a line style this one, okay. Then here certain grid, okay. So when we run this program, so here we are getting say mean absolute error 7.7, root mean square 10 point, mean bias error minus means minus 0.9 means here the model underestimate the value, r square value say 0.39. This is for say basic NN model. Then we are having this LSTM model. For this, here we are getting say r square value 0.36, mean bias error minus 0.36, root mean square value say 10.41, mean absolute error here we are getting 8.01. Okay, so with the help of command, so this is the say difference between say PM 2.54 costed ANN versus LSTM models, right? So in today lecture we will see air pollutant prediction. Now air pollution is a major environmental concern which affect climate, ecosystem and human health. To monitor and say forecast air pollutant level like PM 2.5 PM10, NO2, SO2, O3. In literature, most of the researchers used artificial neural network. As we know that it is a powerful model that learns the pattern from data. But when we consider the accuracy and efficiency of ANN model, it is influenced by the input features which, which we are provided to the model. So here these feature selection techniques play a very important role. Feature selection technique means we have to select important features so that error in accuracy is minimum. Now, what is feature selection? It is a process of selecting most relevant and informative variables, which is called as features, from a data set to train a machine learning model. As we know that in the machine learning model, the target variable is dependent on different types of input variables. But these input variables affect the accuracy of the model. Therefore, we have to use the feature selection techniques, which means of selecting most relevant and informative variables. If we consider this air pollution, these features include the meteorological parameters. This meteorological parameter is say temperatures, wind speed, humidity, solar radiation. Other pollutant concentration like SO2, NO2, and time factor, that is at which time we are collecting the meteorological variables, like here hour of the day of the week, and in season. If we consider any say festival season, it also influence the air pollutant level. Considering the festival season of Diwali, in that case, if we observe the air pollutant of say Delhi, it may get increases due to the burning of crackers. Similarly, if we consider say industrial area, so where demand is more, in that case industry have to produce more pollutant because most of the industries are dependent on say fossil fuel, which is a burning of the coal. If we consider say thermal power plant, there is also burning of fuel take place, fossil fuel take place, which give rise to air pollutant. Using too many features, what will happen if we use too many features? It introduces noise, and it increases training time, and it leads to overfitting. So that is the major drawback of too many features if we use in say AI machine learning models. If we use say too few features, or we can say that if we use a very less features, it may cause loss of information, and it reduces prediction accuracy. So too many features and too few features, both are not beneficial for machine learning model. Therefore, here ANN for air pollutant prediction. Here, artificial neural network is the types of say machine learning model. It is inspired by human brain, and it is composed of neurons. Neurons, I am which has node, and each node perform mathematical operation. These ANN models Um, it develop non-linear relationship between input features. Example here say temperature, wind speed, and output variables. Example here say PM 2.5 concentration, making them suitable for complex environmental prediction. Now, why feature selection matters for ANN in air quality prediction? As it improves accuracy, if we select right features, which means removing of irrelevant or redundant data, help the ANN model to learn faster and better, and it reduce overfitting. Overfitting means here unimportant features can make the model memorize noise rather than general pattern. Speed up training. Fewer inputs reduces the computational needed for training, and it enhances interpretability. Knowing which variables influences pollution helps in decision making and policy information. Now, there are different types of feature selection technique. First one, here say filter method. It is also called as method. It works based on correlation between say input variables and target variable, and we have to see the R value, that is the regression value between each input feature to target variable, and we will take that R value which is having more, or you can say that which is having close to one, and we call that input variables as a important features, and it is fast and independent of ANN models. Then we are having this Draper method. It uses performance of ANN to evaluate different subset of features. So here, first we will form a different subset of features, and then we will see which which features, by combining which features the ANN model is having less error matrix. So here we will do this forward selection and backward selection. In forward selection, first we will take one features, and again we will evaluate the accuracy of the model. Then we have to take another feature, again evaluate the accuracy of the model, and it go on and on. And in backward elimination, first we will take all input features, and by removing some selective features, we will see what is what is what is the effect of that features on uh, say error matrix of the models. So more accurate but computationally expensive. So this is, you can say that it is advantage, but disadvantage is that it is computationally expensive. After this, we are having this embedded method. Here we perform feature selection during model training. So example of this embedded method is a L1 regularization, decision tree importance score. So we are using this L1 regularization in order to improve the training performance of the model. Then we can also use this decision tree. By using decision tree, there is a important scores. So based on that score, we can develop the model. So what are say typical workflow in a study? So first of all, see here, data collection. It means gather air pollutant and meteorological data from sensor or data set. So When we say here data sets, so in India, the Central Pollution Control Board, New Delhi, is monitoring air pollutant data, and that data is freely available. So, for developing the AI models, we can take that data, or by developing the sensor. There is so many low cost sensor available in the in the market. We can use the IoT, that is say Internet of Things, for developing the air quality monitoring devices. So from those sensor we can collect the air pollutant and the meteorological data. When we collected the data, then we can use this pre-processing technique. Pre-processing technique means here we have to say clean the data. What we are doing is say cleaning the data. First of all, we have to handle the missing value in the data, or we have to remove that data which is not in our data set, or we have to keep some average value in place of say missing value. Then normalization of the data by using this normalization techniques, uh, the training get faster. By using normalization techniques, the range of data the range of data lie between say 0 to 1. After this pre-processing techniques, we have to apply the feature selection techniques. Feature selection techniques, there is so many feature selection techniques which is available in the literatures. So by using this feature selection technique, we have to identify the most relevant features. Once we identify the most relevant features, then we have to train ANN model using this selected features as input. Once we train the ANN model, then we can evaluate the model accuracy using say mean square error, root mean square error, mean absolute error, R square value, uh, and and we have to compare the model accuracy with and without the feature selection. Once we compare the error matrix with and without feature selection, then we can know that what is the importance of this feature selection, and what will happen if we use the feature selection techniques in our model. And we can also conclude that by using the feature selection techniques, how much our model accuracy get improved. Now, one feature selection technique that is called as a mutual information. It is used to select important ANN input for air quality prediction. So here predicting air quality accurately is becoming increasingly important due to rise in pollution, and which is caused by urbanization and industrial activities. Air pollutants like PM 2.5, NO2, SO2, and O3 significantly impact public health. One powerful models tool for forecasting these pollutants is artificial neural networks. These ANN are capable of modeling, say, complex nonlinear relationship among variables. Therefore, it is suitable for environmental data analysis. When we say environmental data analysis, this data is stochastic variable. It means that this variable is changes with respect to time. Therefore, high level of non-linearity exists between input variables and say target variables. So when we use these ANN models, it can develop say complex non-linear relationships. But when we consider efficiency of ANN models, it depends on selecting appropriate input variables. Uh, so therefore, we have to apply the feature selection techniques. So one feature selection technique we are going to discuss, that is a mutual information. So it acts as robust method for identify input variables that are most informative regarding the target output. So, considering this, the schematic diagram of the mutual information in selecting optimal input for ANN-based air quality model. So, suppose if we apply this mutual information, which is given by these blocks or this modeling equation or this function. So, what we have seen here, if we take say different types of say input features, say temperature, relative humidity, wind speed, say traffic. Okay, so it will go through this mutual information, and here target variable y say air pollutant variable. So based on the result which is given by say mutual information, so again here in this box we will select the relevant input, and then we will feed that relevant input to the AI models here. So AI models has a, we know that say it has different layers, say input layers, hidden layers, and target and output layers. So based on these variables, we have to develop this ANN models, and we will use this error matrix to find out the accuracy of this ANN model, and then we can use this ANN model for predicting of air pollutant based on unknown value of say input. So here, artificial neural network in environmental forecasting, how we can use this ANN in forecasting of environmental parameters. As we know that these ANNs are computational framework model after human brain neural structure. They work by recognizing patterns in historical data. So we can say that this is the beauty of ANN models. It recognizes patterns in historical data automatically. If we consider air quality forecasting, ANNs are trained using input such as temperature, humidity, wind speed, and direction, atmospheric pressure, and historical pollutant concentration. The key to accurate prediction lies in using only relevant features. So it means we have to include unrelated input, which 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 give rise to overfitting, slow training, and less reliable prediction. Now we will see how we can use this mutual information for uh, for important variables selection. So mutual information is a numerical matrix which evaluate how much information one variable provide about another. It learns nonlinear and linear patterns, which is useful in environmental science where relationship between variables are often complex. How we can represent this mutual information mathematically? So mutual information between say two variable x and y is given by this equation in which this pxy is a joint probability distribution of x and y. Px and Py are marginal probability. Here we are having Px and Py. This is called as marginal probability. The logarithmic is typical base 2 here, given unit in bits. So when variables are independent, their mutual information is 0. Now, what are say benefit of mutual information in feature selection? First, capture non-linear interaction. It reveals hidden non-linear dependencies that traditional correlation method might miss. Model independence. Mutual information operate directly on data without relying on the structure of the prediction model. Efficient dimensionality reduction. By selecting only most relevant features, mutual information simplify input space, leading to faster and more accurate modeling. It reduces noise. It eliminates irrelevant features which help in reducing noise, results in more stable prediction. How mutual information enhance ANN-based air quality model. Selecting the most informative input, different environmental variables have varying impact on pollutant level. For example, PM 2.5 it might be influenced more by wind speed and temperature than by solar radiation. Now this mutual information measure how much each input contribute to predicting the target pollutant. Input with highest EMI score are considered more useful and are prioritized. So this point we should keep in mind that once we got say highest value of mutual information, it means that variable are more useful and we have to keep it in say priority basis that variables. Creating a focused input set. Once mi values are computed, features are ranked. Then a threshold is applied to choose the top ranking variable. Its focus set of features is used to train the ANN, leading to better model performance with fewer inputs. Performance enhancement. Empirical evidence suggests that ANN model trained using mutual information optimized features shows lower prediction error. Higher accuracy means R value, faster training convergence, better generalization on test data. Now, how we can implement this mutual information on any say machine learning model. So, what are the different implementation steps? First of all, we have to gather data. So the data here is say meteorological variables and air pollutant concentration. These data can be collected from monitoring station or by some experimental analysis using say sensors. Then we have to pre-process the data. Why we have to pre-process the data? Because when we are using the sensor in recording the data, some data get missing. So therefore, first of all, we have to handle that missing data. Then we have to normalize the data so that data lies between range say 0 to 1. This is called as standardized scale. After this, we have to compute mutual information. For this, we have to use one tool, say scikit-learn in Python, to calculate mutual information between each features and target pollutant. After this, we have to rank and select features. Choose the top n features based on mutual information score. So once we are able to select important, say relevant features here, then we can use that features in say model training. In model training, we have to divide say data samples, 80% data for training, 20% data for testing. So once we train and test the model, then we have to go for say validation part. It means we have to test the model using standard metrics, say root mean square error, R square value, mean absolute percentage error, mean square error. So once we calculate different error matrices, we will see and we will see how error get reduces before and after feature selection. Now case study example. Suppose a city with high PM 2.5 level. A researcher collect environmental data over several months. Then then researcher utilize mutual information to identify that wind speed, humidity, and past PM 2.5 level are the most relevant predictors. These features are fed into ANNs. The model shows improved accuracy compared to model trained with all available features, confirming the effectiveness of mutual information based selection. What are the different challenges and considerations? While mutual information is highly useful, it is important to know computationally complexity. Calculate mutual information for a large data set can be time consuming. No causal insight. Mutual information measures association but not causality. Discretization needed. For continuous variable, mutual information calculation may require discretization or estimation techniques. Conclusion: mutual information is a powerful tool for feature selection in ANN based air quality model. By focusing on more informative input, mutual information improve prediction accuracy and it reduces model complexity and enhances interpretability. Given growing importance of environmental monitoring, integrating this mutual information into modeling pipelines It offers a practical approach to building more smarter, more efficient predictive models. Now we will see how we can implement this mutual information with the help of this code. So first of all, we have to open this Google Colab by writing in Google, say Google Colab. So once it get open, then we can write this simple code. Import pandas at pd, then import numpy at np. Then for here, from sklearn.feature selection, from this library, import mutual info regression. Then from sklearn.model selection, import train test split. Then again from sklearn.linear model, import linear regression. Then sklearn.metrics, import mean square error R square value. This is used to evaluate the accuracy of the models. Then when we upload all these say libraries in Google Colab, then we will see how we have to upload the data, because uh, because for implementing mutual information data is necessary, therefore we have to upload the data. How we can upload this data? Uploaded is equal to files dot upload. Then in step 3, load the data set, assuming the file is a CSV or Excel. So either your file is in say CSV or Excel. So we have to adjust depend on say file format. So if so here file name list upload dot key. Okay, so this type of code we have to write. If file name is say in CSV, then we have to read the file. Else if file name is say in XLS, then we have to read that file. Okay, else raise value error unsupported file format dot upload dot csv dot xls. So this command we are using, suppose if we are the file which we are uploading is not in csv or xls, so that we can get the information that we have to upload file either in csv or in xls. Then here show the first 5 rows of the data. Here print sample data, display df.head. After this here pre-process the data. Then in pre-processing we have to check for say missing value. So this code we have to use for checking it's the missing value. Then drop row with missing value. You can change this to imputation. Suppose if there is a any say missing value, then we have to drop that rows. Then how we have to use this mutual information for column in df, select data type include is equal to object dot columns. Here is a label encoder df columns, ALE dot fit transform df column. Then step 5, define features and target. Replace target column name with actual target column name. Here example say PM 2.5. Here target column that will be equal to PM 2.5. Then in X we have to take this column is equal to target column, y is equal to say variable df target column. Then in step 6, we have to apply mutual information feature selection. Now, before this step, we have uploaded the data, we have done say data pre-processing. Then we have to apply the mutual information feature selection. Now, once we apply this mutual information say feature selection, here we will get in say M1 scores. Print and top feature rank by mutual information. Then we have to display this mutual information, means this part. In step 7, train a model using say top features. Select top k features. You can change k. Top k is equal to 5. Select in feature midf dot features dot head dot to list. Then what we have to do, x selected is equal to x selected features. Split data into say train and test set. So by using this command, we have to split the data x train, x test, y test. Here train test is split, x selected y, test size 0.2. Then train a regression model. Model is equal to say linear regression. Then we have to do certain fitting, means x train and say y train. Then we have to predict on set test set. Y predict is equal to model dot predict, here x test. Then how we have to evaluate the model? First one with the help of say mean square error, then R square value. So this for calculating mean square value, so we have to write this standard code. For calculating R square value, we have to write this code. Here y test and y predicted means we are when we are taking the data, we are taking some data for training, another part of the data for say testing. So this is called as a testing data, and this is y predicted. It is the say predicted value which is given by the models. Then we have to print all these values. So once we see here, so five row first 5 row here, and all input features here, all input features here. So here missing value in each column, it gives the information what are say missing values. Then after this calculating mutual information, so here when we use say mutual information, say PM 2.5, using say PM 2.5, it is having say 4.80 score. So we are predicting the say PM 2.5. So that's why when we take the same feature, its mutual information score is high. Apart from this, if it you say PM10, here you are having 0.74. If we then bin direction, this mutual information score is given as 0.41. Then we are having say relative humidity. Here information score is given as 0.39. Then here we are having air temperature. Here information score 0.19. Ozone 0.16. Then we are having toluene 0.13. Okay, so that's all for today. Thank you.